Now we would like to go ahead and put this all into practice. So the first thing we're going to need to do is find all rational zeros using the rational zeros theorem, which we've just learned. Once we have all of those, then we're going to pick a zero, a potential zero, plug it into the function, and if the function equals 0, then we've successfully used the factor theorem to find one of the zeros. For part C, we're then going to use long division or synthetic division to get the polynomial down to something that's easier to handle. And then we can repeat steps A through C if the quotient cannot be factored, or if it can be, then we go ahead and solve for the remaining zeros. So let's go ahead and start out here. The first thing tells us go ahead and use the rational zeros theorem, which said we have to look for P and Q, right? So P in this case is -6. Q is 1, right? There's a leading coefficient of 1. And by the way, this is degree 3. So we're looking for 3 zeros or potential zeros. Right, again, they could be repeated. So factors of Q, well, and that's a tough one, right? We have plus and minus 1. For P, we can have 1, 2, 3, or 6. Then remember that the rational zeros theorem says we need to do all of the potential P's divided by all of the potential Q's. So I'm going to come over here and I'm going to do that. So I have plus and minus 1 divided by itself is plus or minus 1. Then we could do 1 divided, 2 divided by 1. Right? Basically, we just get P back because everything is divided by plus or minus 1. So we really have 8 options here, right? Plus or minus 1, 2, 3, or 6. So we need now to plug one of these into f of x and see if it returns 0. Now we could just start with, let's say, 1 and see what happens. So I'll plug 1 in. I have 1 cubed plus 2 times 1 squared, 5 times 1 minus 6. So that's going to be 1 plus 2 minus 5 minus 6. I can already tell this is not going to give me 0, right? This is going to be, looks like negative 8, if I didn't lose my mind there. Let's see, negative 11 plus 3 looks like negative 8. All right, so that obviously is not one of the roots. Okay, let's try a different value. Maybe let's go ahead and try negative 1. Negative 1 cubed, 2 times negative 1 squared, minus 5 times negative 1, minus 6. So that's going to give me negative 1. Negative 1 squared is positive, plus 2, or times positive 2 is 2. Negative 5 times negative 1 is plus 5. And then we have minus 6. So it looks like we have 5, 6, 7, and then minus 7. So this one looks like it works. So I get a 0. Now remember, that means that if negative 1 is the 0, then the factor is x minus c. So our factor here, or that we expect, is x plus 1, right? Because it was x minus a negative 1. So now we need to take that and use our synthetic division or long division into the original polynomial. So let me grab the polynomial here, x cubed plus 2x squared minus 5x minus 6. Okay, so I could just scroll down. All right, I'm guessing you guys would all like to do synthetic. We can because the leading coefficient's a 1. Remember, that's not the case otherwise. Okay, so plugging or taking all of the coefficients, we have 1, 2, -5, -6. And here we have our value of C, which was -1. So we bring this down, multiply. So -1 times 1 is -1. And then we add down the column. So 2 minus 1 is 1. Multiply -1 by 1. We get -1. Add down the column, we get -6. -1 times -6 is +6. -6 plus 6 is 0. That's our remainder, right? If this was not a factor, our remainder would not be 0. So we're good there. Then remember, this is our constant. And then the x term and x squared term. So currently we have now as our factorization x plus 1, and then we have x squared plus x minus 6. Now we would like to go ahead and factor that if possible. So here we're looking for two numbers that multiply to -6 and add to +1. So those would be the factors x plus 3 and x minus 2. Once we have this factorization, right, we would set this equal to 0 and solve for the roots. So we have x plus 1 could be 0, x plus 3 could be 0, or x minus 2 could be 0. And this gives us -1, -3, and 2. Now let's go back up and just make sure that those were all possibilities that we saw before. Right, again, that's another good way to check and make sure we're doing the right thing. So the possibilities were 1, 2, 3, and 6, and they could be plus or minus. We got -1, -3, and +2. So all of those were possibilities. This all looks like it works out. This was a pretty simple example, but it works out really nicely and easily for us. Let's go ahead and move on and take a look at another example. For our second example, right, again, we need to start by finding all rational zeros by using the rational zeros theorem. So first we need to start by saying, okay, this is degree 3. The value of P is -3, and the value of Q is 1. So our potential factors for P are plus and minus 1, plus and minus 3. And for Q, we simply have plus and minus 1. So this doesn't look like it's going to be too bad. Then for the rational zeros theorem, it's P divided by Q, or the factors of P divided by the factors of Q, I should say. So we get plus and minus 1 for plus and minus 1, plus and minus 3 over plus and minus 1. Okay, so our possibilities then are just plus and minus 1 or plus and minus 3. So there's 3 roots, 4 possibilities. I'm assuming we're going to get something that's repeated here, but let's find out. Use the factor theorem until a 0 is successfully found. Okay. So this was part 1. Part 2 says use the factor theorem. So we need to plug one of the values in. So G of, and I don't know, let's pick 3 this time. So we need 3 cubed plus 7 times 3 squared, 11 times 3 minus 3. Now, before I even evaluate anything here, I can clearly tell this is not going to be 0, right? Because all of these numbers are going to be positive except for the -3. So I'm just going to go ahead and stop there. And let's plug in something else. Right? Let's plug in -3 instead and see if that's a possibility. -3 cubed, so that's -3 times -3 times -3. That's going to be -27. -3 squared is 9. 9 times 7 is 63. 11 times -3, that's -33. And then -3. So we have -27 and -3, that's -30, plus another -33, that's -63. So this looks like it is, in fact, going to be one of our factors or one of our roots. So I missed my negative right here. So the root is -3, which means x plus 3 is the factor. So this is the root. This is the factor. Let's go ahead and use our synthetic division. So we're plugging in -3 out here, and then our coefficients were 1, 7, 11, and -3. Bring down the first value, multiply, add down the column, multiply again, add down the column. -3 times -1 is going to be +3. That's fantastic because we get a 0 for the remainder. That tells us that we're on the right track. All right, so we have x plus 3 is one of the factors. The remaining factor, this is the constant. This is the x term. This is the x squared term. So we have x squared plus 4x minus 1. At the moment, we have that this is g of x. Now, because this can't be factored because it's prime, right? We can't think of something that we multiply to get -1 and add to 4. We need to just use the quadratic formula. So basically, when we get to the point where we have a squared or a quadratic factor that's left, then we're going to either factor or use the quadratic formula. That's something that we've gone over, so let's go ahead and use that to find our remaining factors. So we have x equals the opposite of b, so -4, plus or minus square root b squared minus 4 times a times c. Remember that I'm getting these from the ax squared plus bx plus c form, all over 2 times a. All right, and then we're going to simplify this best we can. So 4 squared is 16. Then we have 4 times 1 times -1. That's -4, and it's minus, so that's really +4. All divided by 2. Then we get -4 plus or minus. This is square root of 20 over 2. So that's -4 plus or minus. Now 20. Let's see, does it have any? It has 4 hidden inside, right? It's 4 times 5. So that's a perfect square that we can pull out. So this is going to be 2 root 5 all over 2. And then finally simplifying, we get -4 plus or minus 2 root 5. Each of these divided by 2, which is -2 plus or minus root 5. So these are our other two potential roots, right? -2 plus root 5, -2 minus root 5. The other comes from x plus 3, right, which we already solved for, and that was x equals -3. One thing to note, right, we have this -2 plus or minus root 5 here. You recall that I said in the previous example, if you get roots that are not the possible roots, that might be something that something to tell you you've made a mistake. But you'll notice that the theorem, the whole thing that we're doing here, this is rational zeros, right? Rational meaning that it's actually a whole number or can be written as a ratio. These are actually considered irrational. And there's no way for us to find all of those. All right, and then let's go ahead and hop over to Desmos. I've already plotted the function here. It's in red. I've also plotted all of the zeros, right? -3, 0, -2 minus root 5, 0, and the final one here, -2 plus root 5, 0.